Now this question is given in GATE 2000. Suppose the time taken to service a page fault is on average 10 milliseconds, while a memory access time is 1 millisecond, which means they are talking about the page fault as service time. Service time is 10 milliseconds and memory access time is 1 microsecond, and 99.99% is the hit ratio. If the hit ratio is 99.99%, then they are saying so see, if the hit ratio is 99.199%, then what is the miss ratio? 0.01%, isn't it? Then they are saying the average access time is how much, right? So I told you this average access time is, or effective memory access time is, always equal to, memory access time plus P is page fault rate, not the hit rate. P is page fault rate into PS is page fault service time. And now what is the memory access time they have given? The memory access time is given as 1 microsecond. So 1 microsecond means 10 power minus 6, or you can leave it as 1 microsecond as it is. 1 microsecond, right, plus P. What is P here? In this formula, P is miss rate, right? P is the miss. But then here the probability given is hit rate. So if hit rate is 99.99%, then what will be miss rate? 0.01%, right? 0.01%. When you convert 0.01% to fraction, it will come to 0.0001, isn't it? Divided with 100, right? And into page service time. So how much is page service time? Page service time is, they are saying that it is 10 milliseconds, which means 10 into 10 power minus 3, right? So it is already 1 microsecond plus, if you compute this all, it is 10 power minus 4 into this is 10 power minus 2, right? Therefore it is 1 microsecond plus 1 microsecond, so which is equal to 2 microseconds. So 2 microsecond is the answer. But then if you look at the answers, 2 microsecond is not there. Only the closest answer is 1.999 microseconds. Let's see, why do you think that they got their that difference? What is the why they are given this as the answer 1.999 is, if you observe it, the formula which I got here, I derived it on the basic formula of this. So the basic formula was effective memory access time. I have taken it as, if there is a page fault, right, then there has to be a page service time. So what is the page service time? The time taken for me to get the page into the main memory, and after getting the page into the main memory, I still have to access the main memory to get that word. See, initially I wanted a word and the word was not there because page was not there, and therefore page service time is just going to get the page in the main memory, and again I have to start the same instruction and get the word again, right? So even after page service time, I am supposed to access the memory, right? So for that, what happens is P into PS plus, again memory access time has to be included, right? Plus, in case if it is a hit, so if misses, this is a miss rate, right? If it is missed, then I need all this. In case if it is hit, then I don't need the this one. Then based on this, I got this formula. If you expand this out, then I am going to get P into PS plus P into M plus M minus MP. See, we have already seen it, but I just wanted to show you because they are showing it as different. That is why I just want to tell you what the mistake is, right? So now this is how I got it. So this is the formula, M into P into PS, where P is the miss rate, not the hit rate. Fine. So this is the actual formula. But then what many textbooks, including Galvin and many other authors, many other popular authors, what they did is, they are not considering this. The reason why they don't consider this time is, it is very, very small compared to this, and so it is negligible. But many times what is happening is, in the numerical questions, if you consider this, we are getting a different answer, and which is right. And theoretically they have just eliminated it, saying that main memory access time is very, very fractional compared to the page fault service time. That is true, it works in theory, but when you come to practice, it is not, in some of the numericals, they are giving the numbers so close. See, these numbers are not very much far away, isn't it? So this is 10 power minus 6 and this is 10 power minus 3. They are not very much far away. It is not nanoseconds and then seconds. So in this case, there is a fractional marginal difference, right? So the formula which they have used is, they didn't have this one, right? And if you substitute directly in this, you will get that answer. Effective memory access time is, what is the P? Page fault rate is how much? P is page fault rate, right? So page fault rate is 0.01. Sorry, 0.0001 into what is page fault service time? Page fault service time is 10 milliseconds. 10 milliseconds is 10 into 10 power minus 3 plus 1 minus P is 9999 okay, into memory access time. What is memory access time here? So memory access time is 1 microsecond, which means 10 power minus 6, right? So now if you add both of them, see, this one is going to be 1 microsecond, 10 power minus 6, and this one is going to be 0.9999 microsecond, right, into 10 power minus 6 seconds, right? Now you get it as 1.9999 microseconds. Yes, this is how we got the answer, right? So why? Because they neglected this part, but actually this has to be included, and this is the right answer. And the irony is, this one looks like the exact answer and this one looks like an approximate answer, because whenever we have these many decimal points, we might think that this is the exact answer and this is the approximation, but actually this is the exact answer and this is the approximation. Exact answer is more round figure here, right? So what should you do in that cases is, one thing is, whenever you solve the answer using this formula, whatever answer you get, that will be very very close to the options given. See, since gate question is given this way, I cannot change the concept and then explain you this to get this answer. I am just telling you what is right, and in case if the question given is wrong, I cannot do anything, right? So seriously, we can't do anything with these many people setting the paper every year, and whenever these professors they change, the books they follow, they are changing, therefore the concepts they have learnt, they change, and depending on what they know, they are forming the question, but not on depending on what is right. What they know, they are forming it, right? Then there is confusion really. But then let me tell you, if you follow the right method, right procedure, always there is a chance that your answer will be closest to the whatever answer they give you, right? In this case, just check it, no other answer is even close to this your answer, right? Therefore you can definitely go close to the answer. And second thing is, don't change your concepts because some questions are given wrong, right? And because we should never do it. What if they really follow the real concept tomorrow and give the real question? What if they realize that it is a mistake and maybe they add marks or change the question and then maybe they add marks to others? So let's follow the concepts right and let's not follow the questions. So what my intention is, even though a question is wrong, I'll explain you why that is wrong and I'll explain you the right method too. And it is up to you to follow the right method, okay? Don't follow the questions, follow the concepts, right? So always this is right, okay, and this is wrong, and it will give you approximate answer and it will give you correct answer. I hope that you understood this concept. Okay, fine.